Start the recording. And the first slide, this is today's storyline. So Dr. Evilo, I guess he isn't that bad of a guy. He wants to stop pollution. And we all know trees play a part in what? And plants play a part in what? Stopping pollution or global warming. So he has an evil plan. He has invented a chemical that will change people into plants. It's like a double-edged sword here. He's doing something good and bad at the same time here. How much of you all agree with Dr. Dr. Evilo's plan here at the moment? What do you all think of this? Let me hear your thoughts. All right, so hoping you're hearing the audio. So guys, just like last week, only one person is going to survive today, right? One person. Choose your character, and one by one, they will be changed into plants. Who do you think will be the person who will not be changed into a plant? Write down the character's name, and you cannot change it for the entire class. So I'll give you all, All right, so this is where we ended off last week, right? And we were basically trying to differentiate functions. So the good news is the formulas are still here, right? But I want to change up the first question. So when you're differentiating sine and cosine and whatnot, once you memorize the formulas, you should be good to go. Right, so let's just make sure that you can utilize these formulas. So let me change up the first question, because last week a lot of you all attempted that question. Right, so let me change this here into, change up these two values here. And change it into, let's put 5 and let's put minus 3x here. Good luck, guys. I want you all to differentiate these two things here. It only looks complicated, huh? But remember, is pi on 2 a variable, or is pi on 2 a regular boring number? Well, what do you all think? Is pi on 2 a variable or a regular boring number? It's not a variable. I mean, it looks complex. To be a variable, shouldn't you have an x or y attached to you? Think about it. Is 5 a variable? No, this is a regular boring number. It's a constant, right? But if I put 5x, then it becomes what? A variable. Remember, b over here represents a regular boring number. It's a constant. Why isn't pi just 22 over 7? Are there any x's attached to that? No. So pi, or even pi on 2, is a regular boring number. It is a constant. Don't let the pi fool you to think it's anything special in this scenario, you know. Okay? Pi on 2 is a regular boring number, a constant, and it's b is representing that regular boring constant in the formula. So good luck, guys. Differentiate both of them using the formulas and send it on the chat. It might be a little headache to type up the answers on the chat, but you know, try your best to still set a question. Now, you have to remember, things like trigonometry, like sine and cosine, I think, have their own set of rules when it comes to differentiation. Huh? And these here are the set of what? Rules. So in the first one, which one of the formulas does this represent? Does everyone agree that the first question, we have to follow this format? Because we're trying to differentiate sine, and you have two items in the brackets. One with x and one without x. If you all notice, when you differentiate sine, we're supposed to change the sine to cosine. You can clearly see that in the formula. Also, you notice whoever is touching x, in this case here, it's a. you throw or photocopy the A outside. Photocopy means that you make a copy, which means the A still remains inside. You're just throwing a photocopy outside, okay? And you write back the items in the brackets exactly the same. So you're just trying to imitate that format. So let's see what's going on here. Well, we see we have a sign. This comes like the A, this comes like the X, and this comes like the letter B. Remember, the letter B is just representing a constant, a number without an X or Y in it, okay? So when you differentiate this, let's do this slowly. When you differentiate Y and X, you're going to get dy dx. Doesn't A get thrown outside? Also, the sign will change to what? Cosine. So I made sure and change the sign to cosine. Remember, there was a 5 outside waiting here. That came with the formula, but with the equation, sorry. Whoever is A, which is -3 in this case, he gets photocopied outside, right? So a parallel multiply there. The A goes outside. The sign changes to cosine, and we have to write back whatever is in the brackets exactly the same. So it will be -3x plus pi on 2. Now, do me a favor, because this is what the examiner will want. Do not convert the pi on 2 to a decimal. Write it back as pi on 2. You see, when you convert pi on 2 to a decimal, you'll be forced to round it off, thereby decreasing the accuracy of the question. Leave it as pi on 2. So my final answer will be this. Since the -3 meets the 5, -3 by 5 is -15, right? You must simplify it for the examiner. That's understood in maths. And you just write back everything exactly the same in the brackets. For those who got it wrong, you think you understand your mistake, you're going to get a second go at it when I start to explain the next question, all right? So look for your mistakes, right? Make sure to internalize it. Make sure you understand what you got wrong. Right? Great. Let's try the second question. Okay. The second question, right? This question can be broken up into 2 parts. You'll realize that this section here is completely separated from the 3x. Like it have a big positive sign in between the two. So this comes like 2 separate questions. So when you have separate things to differentiate, you can just differentiate each one separately. Let's do this one first. This one is pretty easy. We've been doing this for about 2 weeks. When you differentiate a number touching x only, what do you all get? A number touching x only. No, Javon, check it back. No, that's wrong. Come, guys, go back into your notes. Whenever you have a number touching x only, what do you all get? Right, you're just left with the number. All right, you're just left with the number. So it's 3. If it was a number standing by itself, like 5, and it had no x's attached to it, when you differentiate a number standing by itself with no x's, then you get 0. All right, so if you look back in your notes, you will see that clear as day. All right, great. So let's move on now. We still have to differentiate this expression. Well, doesn't this come like A? Doesn't this come like X? And doesn't this come like B? But we're using this formula now, the last formula. So be careful, huh? When you differentiate cosine, you get sine, but you get a minus sign as well. So when you differentiate cosine, you get minus sign. The rest of it is no different. Whoever is touching x gets photocopied outside. So whoever is touching x goes outside as well. And then you write back the brackets exactly the same. So let's put that into effect. When you differentiate cosine, you get minus sign. So do we all agree, since that this formula comes with a -4. When you differentiate cosine, you will get minus sign, and the minus sign will touch this minus sign, like how it already came with a minus sign, and two minus signs will give you what? A positive. Could we all agree on that? So you all understand how we got +4? Because it came with a minus sign. And the formula says when you differentiate cosine, you get another minus sign. So 2 minus will give you a positive. Also, whoever is touching x gets photocopied outside. So the 2 gets photocopied outside and it meets the +4. And then you write back the brackets exactly the same. Right. So 2 by 4 is 8. Sine, open brackets, 2x plus pi on 3. And don't forget the +3 that we differentiated at the beginning. That's our final answer. Look at it. Make sure you understand it. I'm going to give you a half a minute to take down anything you need to take down, and then we will be moving on. All right, who do you think is the first to go here, guys? You want to take a little bet here? Who do you think will be the first to be turned into a plant? Take your guesses, take your guesses. All right, let's see. Oh, sorry guys, anybody chose Oliver? Oliver is the first to be changed into a plant. But let's look at the little animation here. Oh, Oliver is going to change into a plant. So whoever chose Oliver, sorry guys, you are out of the game. Poor Oliver just went in for a coffee and he changed into a plant. Such is life. All right, so let's move on. Oh, and well, Marlon, Oliver was from Trinidad. All right, guys. So you all remember this from 2 weeks, but from I think last week. You all remember this thing called the chain rule. Remember, today we cannot use the shortcut for the hostage situations, and we just cannot. So today we're going to be using the chain rule, but I'm going to make sure and incorporate some trigonometry in it. Okay, so I'm going to give you all a little head start on this question. This here is a hostage situation. Let me explain why. At first, it doesn't look like a hostage situation, but doesn't square root mean to the power a half? So I could throw away that square root, right? And replace the square root with the power a half. If you don't like the power a half, you could just replace it with 0.5. Okay? Right. Get started on this one, right? Right? It's going to be a little difficult, right? But just give it a try. You're using the chain rule. Give it your best shot. You all will notice that you have to, at some point, you're going to have to differentiate minus cos 2x, right? Remember, I'll just clear some space here, right? When you differentiate cosine, remember you all get minus sign. I want you all to view this like this. This is minus cos 2x, but it is usually have something plus over here. Here we have nothing, so you can assume it's what? Plus 0. But nobody in their right mind does do what? Put plus 0. It just looks weird. So you just kind of leave it out, right? So keep in mind, when you differentiate cosine, you will get minus sign. So I have a good feeling 2 minus signs are going to end up touching to give you a positive. Also, whoever is touching x goes outside, but gets photocopied outside. So two things I want you to remember. Look out for two minus signs touching, because if you look back in your formulas, when you differentiate cosine, you get minus sign, and whoever is touching x gets photocopied outside as well, right? Right, so take a minute again, and I will work it out in full. For those who finish and you pretty much understand, you have about half a minute to sit back and relax and imagine who would be the next person to be plantified or change into a plant. All right, so we know Oliver, the owl is gone. Poor Oliver changed into a plant. Not even too sure what kind of plant that is. Let's see who is next to be changed into a plant and do their part to stop global warming. Anybody chose Peg? Yes, I remember a good few people choosing Peg the penguin. Poor Peg. Poor Peggy. There she goes. And it's changed into a flower plant. Anybody out of the game now? Anybody out of the game? For those who chose Oliver, well, you're technically out of the game. For those who chose the penguin, you're out of the game. But that doesn't mean you can't stop guessing, right? If you're out of the game, just choose somebody else. Just choose somebody else. Right? I don't want you just. All right. Let's move on. All right, guys, so something new now, something called the product rule. Before you take down the formula for the product rule, and the good news is this formula is written on the formula sheet. But I want to explain when you use the product rule, right? When you use the product rule. The product rule is used when you have two groups of x not being added or subtracted. For example, if I have 2x plus sine x, this is one group of x and this is another group of x, but they're separated by an addition sign, or in some cases, they'll be separated by a subtraction sign. Whenever you have two groups of x separated by an addition sign, this is nothing special. You would just differentiate him separately and him separately. However, if it was not an addition sign, let's say I change the question to this, 2x sine x, where they are now separated by a multiply sign. Whenever you have two different groups of x separated by a multiplication sign, in order to differentiate this scenario, you have to use something called the product rule. This here is the product rule. Take it down and don't worry. I'm going to show you how easy this is to use. It only looks scary, but I guarantee you it's going to be very, very easy, especially if you remembered what went on last week, right? So take down the formula. Let me know when you're ready to, do this question. And I'll take my time, obviously. I'll take my time. You're going to need to remember the shortcut to help you out here. This is where the shortcut for the hostage rule really, really pays off, right? Last week, you all see this part here. If I have 3x minus 5 to the power 4, and I ask you all to differentiate this, just differentiate that, but don't use the chain rule. I want you all to use the shortcut. So go back in your notes and see if you can remember how to differentiate that using the shortcut. You see, when you have sometimes the product rule just have the hostage rule mixed up in it. And whenever the hostage is not the main part of the question, right? Whenever it's not the main part of the question, I really, really urge you all just to use the shortcut. The examiner will not take away marks. I'm 100% sure. So differentiate this part only and send it to me on the chat, and I will show you why I'm asking you to refresh your memory on differentiating that scenario. Right, so take a half a minute. The shortcut to differentiating the hostage situation, you just throw the power in front. So the 4 goes in front, right? Right, so we throw the 4 in front, and you minus 1 from the power. So if the power was 4, you minus 1, right? So you throw the power in front and minus 1 as usual. Whatever you have in the brackets, you write it exactly the same. You don't change anything. But whoever is touching X, in this case he has 3, he gets photocopied outside. So the 3 gets photocopied outside, and of course it meets Mr. 4, and you get 12, 3x minus 5 to the power 3. Right? A few people had it wrong, right? For those who got it wrong, you think this refreshed your memory? If you go back in your notes, you'll see multiple examples of me doing it via the shortcut method. All right. Everybody good there? Now just a quick refresher. So, and I'm going to be doing this back again. Okay. So what's going to happen now? We have 2 groups of X. If you have 2 groups of X, what I want you to do, the first group, which is 2X, you always call that the letter U. The second group of X, which is the 3X minus 5 to the power 4, you call that V, always. So the first group of X, call it U. The second group, call it what? V. Everyone do that for me exactly like how I have it. When it's 2 groups of X being multiplied by each other, because there's a secret multiplier in between here, circle the first group, call it U. The next group, call it V. So this means the letter U is equal to 2x. The letter V is equal to what? 3x minus 5 to the power 4. That is what we're effectively saying. U is equal to 2x and V is equal to this expression, the other part of the expression. Now, here's what I want you to do now. I want you to differentiate the first expression. Now, if you differentiate the first expression, since it has U and X in it, when you differentiate it, you will get du dx. And then I want you to differentiate the second expression. The second expression has V and X in it. So when you differentiate that, you will get dv dx. Right? So differentiate this and differentiate this, and send the answers on the chat. Great. So I didn't get this part on the recording, but all I did was put all 4 things together, and I have it in brackets here. Do you think this one could be simplified? Does this one have the ability to be simplified? What do you guys think? I think a little bit of simplification can be done, right? I think a little bit can be done. Like, for example, now you see when things are like the whole thing is to the power 3 and thing, don't expand those brackets. Let me clear up one thing in maths. If I have the number 3 outside and I have 2x minus 1, it has no power here. Look at where this pencil is, and there's no power there. Is it okay to multiply that out in maths? So is that a normal thing to do? If you wanted to, could you do that? The answer would be what? Yes, right? And you could do this. Everyone in the brackets gets multiplied by 3. 3 by 2x is 6x, and 3 by minus 1 is minus 3. That's okay to do in maths. But if I have 3 open brackets, 2x minus 1 to power now. It could be 2, it could be 3, it could be 4, it could be 5. Is it okay to say 6x minus 3 squared? Can you do that in maths? Whenever there's a power here, can you still multiply everyone in the brackets by the item outside? The answer is no, right? You can only do it when you don't have a power here. The point is, do not make the mistake and think you can multiply everyone in this brackets by the 12. Don't ever make that mistake, because that whole thing is to the power 3. And you cannot multiply everyone inside here by 2, because it's the power here is what? 4. But there is something we could simplify. There is something to make it a little bit easier, right? Couldn't you multiply the 2x by the 12? Couldn't you just multiply the 2x by the 12? I mean, this is 2x. So you could put that as what? 24x. And then the open brackets, 3x minus 5 to the power 3. That is this guy here. Plus, unfortunately, if you don't like how the 2 comes last, you can probably put the 2 in front. It looks a little bit neater. This would be my final answer for the exam. That would be my attempt to simplify it. And I will not go any further than that. Some people might try to factorize out a few things, but I guarantee you that will not be necessary. Write down up to there, and you have it correct. I know you all want another example, but take a 30 seconds, take down anything you need to, and we're going to do a second example, right? But I think you all deserve a small little break here. All right, so 2 people are gone. Peg the penguin, and who's the other one? Oliver the oil. Who do you think is next, guys? Who do you think the unlucky animal will be? Let's hear you. For those who are out of the game, still take a guess. You could still be part of the game, right? You could still be part of the game. Yes, like I said, the music is giving a little bit of problems. I don't know why. Tim, somebody said Tim, somebody have it out for the goat. Yeah, Lee. Well. All right, let's see who's next to go. Let's see who's next to go. I'm hoping it's Carl the crab. Oh no, it's Tim the tiger. Anybody chose Tim the tiger at the beginning of the game today? Poor Tim. He drank the coffee and turned into a plant. Poor Tim the tiger. All right. Let's move on. I want you all to try this one for me. Now, let me explain what's going on in this one here, right? These are indeed 2 groups of, I made a slight mistake in this question, right? Let me show you what the slight mistake is, right? Let me correct the question. Right? There's a slight mistake here. A changing of the question here, right? I want this to be x to the power 3. Differentiate that for me. You notice it's 2 groups of x cubed, and it's being multiplied by sine 4x. So this come like the letter what? U. That's the first group, and the second group is V. Good luck, guys. All right. So just a little bit of assistance, right? Remember, sine 4x comes like sine 4x plus 0. Remember, when you differentiate sine, you get positive cosine. If you look at the formula, then you write back everything in the brackets exactly the same, but you don't have to write the 0, right? I mean, eventually I will erase the 0. And whoever is touching x gets photocopied outside, right? So your final answer will look like this: 4 cos 4x. There's really no need to put our brackets here. And of course, you're not writing the 0. So I hope when you all differentiated sine 4x, you got 4 cos 4x. Right, so that's a little bit of assistance there for those who are a little bit lost. You still have a minute again. Great. So let's see what's going to go on here, right? Oh, sorry about that. It's now, right. Let me erase this piece here. Remember, we're breaking it up into 2 categories, right? The first group, right? We always call it U. So U is equal to x to the power 3. V is equal to the other group of x being multiplied to it. So you get sine 4x. Let's differentiate each expression. When you differentiate the first one, because it has u and x in it, you're going to get du dx. You throw the power in front, you're minus 1 from the power. But that one is easy. When you differentiate the second expression, you're going to get dv dx. Now, I just did this differentiation for you, but I'll just repeat it. When you differentiate sine, you get cosine. Whoever is touching x goes in front. It gets photocopied in front. And whoever comes after, you just write them back exactly as it is. How much people had up to there? Like you had all the differentiation correct up to there. Right. Now, guess what? You just have to put all 4 things together. And the nice thing about it, you don't even have to memorize this equation for the examiner. It's given to you on the formula sheet. So we just have to take u. How much is u? U is x cubed. Multiply it by dv dx. We have an expression for dv dx. Look at it. dv dx is equal to this. So I'll put it in brackets. 4 cos 4x plus, that's part of the formula. V, where's V? V is this guy here. Sine 4x. And how much is du dx? Where du dx? That's this guy here. I'll put it as 3x squared. Now, let me just explain something about sine, tan, and cosine. They're kind of funny. If I have sine 4x, and afterwards, let's say if I had 2 in brackets after, don't ever make the mistake and think it's okay to multiply the 2 by the 4x to get sine 8x. That's 100% wrong in trig. Trigs just have this weird rule. You see the sine 4x, you see who comes directly after the sine? They belong to the sine. And they are not allowed to mingle with anybody else. So this 2 just can't come here and say, I'm going to be multiplied by the 4 to get 8x. Unfortunately, you have to leave it in brackets, or you can put the 2 in front. You just have to accept this. This is just how trig functions are stated. Okay? The reason I'm telling you that, it's because you will be tempted to do it over here on top. When you're simplifying, right? You'll be tempted to say 3x squared, and you'll be tempted to multiply it by the 4x. So you will say, well, 4 by 3 is 12, and x by x squared is x to the power 3. And you'll put back Mr. Sine here. That's not allowed in maths. Instead, I would take this and I would just put it in front to make it look a little more pleasing to the eyes. So my final answer will be this. 4 by x cubed is 4x cubed. You don't have to put the 4 first. The 4 can come after. You have cosine 4x, right? Plus, I'll put the 3x squared in front to make it look a little more pleasing to the eyes, and put the sine 4x. Or you can leave it in brackets here, but I don't advise you do that, because when you leave it over here, somewhere down the line, I think you'll get tempted and you'll multiply the 4x by the 3x squared. But if you write it in front, like you shift it to the front, you won't be tempted to do that. All right? How much people got this answer here? Okay. or something super close to that. Obviously, everybody might rearrange it a little bit different, right? Remember, multiplication, it doesn't matter which order. 2 by 3 is the same thing as 3 by 2. It doesn't really matter. So that if I multiply two things, it's perfectly okay for me to throw this in front. Maths doesn't really care about the order of multiplication. Right? And that's your answer. I don't think that could be simplified any further. All right. Who do you think is next to go, guys? Who went? Oliver went. Who went? Peg the Penguin went. Somebody else went a little while ago. Tim the Tiger. I'm going with Gary the Goat. I really can't remember who's next. I'm going with Gary the Goat. I think his time is up. Time for him to finish out. All right, guys, let's see who's next. Oh, it's Sarah the snail. Poor Sarah, she's probably too slow. And the coffee patched up. Bye, Sarah. She's from which country? Which country is that? Oh, that's Barbados. Right. All right, so let's move on. All right, I want you all to try this one for me. This one is a little bit, it has a trick in it. By the way, this x to the power -1, this -1 only belongs to the x. It does not belong to the 3, but that's not the trick in the question. Good luck, guys. I'm going to give you 5 minutes with this one. This is actually a past paper question. So let's see how you handle it. And it is the product rule because this group of x is being multiplied by this trig function here, which has an x in it. So it's two groups of x. 5 minutes. Right. I think the first part is pretty easy, right? I mean, I point this out to you. This is u, and this part is v, right? So I'm going to just write what I just said. U is equal to 3x to the power -1, right? The second part is v. V is equal to cosine pi minus x. Now, I just responding to a couple suggestions, right? Remember, is pi a regular boring number? We said that pi is just a regular boring number, right? Isn't it possible to rearrange this like, I mean, if you wanted, right? Isn't it possible to rearrange it like this? Cosine, and I put the x minus pi. Is that possible? Do you think we can do that? Because according to the formula, I gave you this, ax plus b. There should always be something touching x and something without an x. Is this correct? Is this rearrangement correct? Like I could put the x first, because according to the formula, the x's come what? First, right? Is that okay to do? Is that rearrangement correct? Or is something wrong there? Nah, that's wrong, guys. That is wrong. How come over here the pi is positive, because this is positive pi, and over here the x is negative? But when I rearrange it, how come the x is positive and the pi turned negative? Remember, if you're switching something around, you have to carry the signs with it. So the correct way to rearrange this, right? I mean, if you wanted to, I don't really think it's necessary. You have to put minus x plus pi. When you're rearranging something, you have to carry the signs with it. You just can't change the signs. Like if I have 2 minus 3, now we all know this 2 is positive. If you rearranging it, you have to put minus 3 in front and positive 2 after, right? But I don't even think rearranging it is really, really necessary. Because when you differentiate cosine AX, right? When you differentiate it, when you differentiate cosine, what do you get again? Minus sine. You write back the brackets exactly as it is. And whoever is touching X gets photocopied outside. So two things to remember. Well, even though you have the formula already, when you differentiate cosine, you get minus sine. You always write back the brackets exactly as it is. And whoever is touching X gets photocopied outside. That is all you really have to remember. So where am I going with this, right? And you'll see in a little while. What number is touching X? Anybody wants to tell me, if I write something like minus X, what number is automatically touching X? What number is understood there? It's a 1. Well, it could be minus 1, right? Because it have a minus here. No examiner is going to write in that pink 1 for you. You have to know that there's a 1 over there. And it's not 1, it's minus 1 because it have a minus sign here, right? That came with the question. So let's differentiate now. If we differentiate u and x, you're going to get du dx. You throw the power in front. So we're going to throw the power in front. Everyone agrees that the minus 1 will meet the 3 to get minus 3. I don't think I need to show that step, right? The minus 1 gets thrown in front. Minus 1 by 3 is minus 3. And then what do you do with the power? You minus 1 from the power. Minus 1 minus another 1 is minus 2. So I hope everyone has that correct. Let's differentiate this expression now. dv dx. When you differentiate cosine, you get minus sine. You write back the brackets exactly as it is. And whoever is touching X, remember we said it over here, whoever is touching X gets photocopied outside. Who's touching X here? Not 1, but minus 1. This minus sign belongs to the 1. So who gets photocopied outside? The minus 1. You'll realize 2 minus signs will touch here to give you a positive 1. And 1 multiplied by anything is itself. Everybody, this is the best I can explain it, right? How much people at least got this, right? The minus 1 went outside to meet another minus sign, and 2 minus signs will give you positive 1, and 1 by anything is itself. Now I'm going to clear up this mess here, right? I'm going to clear this up here, right? Minus 1 by minus 1 is positive 1, right? I really don't need to write the positive 1 because that's like saying positive 1 multiplied by 2. Who writes it? And positive 1 by 2 is just 2. So if I have positive 1 multiplied by sine something, why even bother to write the positive 1? It's unnecessary, right? It makes it look necessarily complex. Also, I don't need to put this 1 here, and I don't need to put this 1 here because it's understood that there's a 1 there in any case, right? You have to imagine that 1 over there. So you could do the calculation. All we have to do now, guys, is put all 4 together. All 4 things together. So let's start, right? U is how much? Where is U? 3x to the power minus 1 multiplied by what? dv dx. Where's dv dx? So dv dx here. That's how I made a small mistake. It's x here, not 3. Plus v. Where's v? V is this guy here. Plus pi minus x. And du dx is minus 3x to the power minus 2. I don't think that this can be simplified much, but the only thing I will attempt to do, right? I don't like how this comes last. I prefer this to come first. Now, if I throw this in front here, The positive will meet the negative. When a positive and a negative meet, you will get a negative. I just find it looks neater like this, right? I mean, if you leave it like this, I can't see the examiner taking away any marks, but that isn't much of a simplification I did. That isn't much. Right, so how much people got that 100% correct? There's two things I'm asking for. If you got it 100% correct, put 100% correct. If you finally understand it now, that means you got it wrong before. If you finally understand it now, let me know, understood. Right. I know some of you are going to have to watch back this again. All right. Who do you think is next, guys? Timmy the Tiger is gone. Oliver the Owl is gone. Peg the Penguin and Sarah is gone. I say Gary. Time for Gary the Goat to go. All right. I think was Sally. Let's move on. Let's see. Oh no, it's Marvin the Monkey. Anybody had their hopes and faith underneath Marvin the Monkey? Sorry, Marvin, your time has come. Anybody knows which country this is? With the 2 stars? I can't remember. I'm not too sure if that's St. Lucia or St. Venus. I'm not too sure. Anybody know? Oh, Marvin. That's somebody said it's Dominic. Let's move on. All right, guys, now here's what. We're not going to be able to do this one today. We only have 15 minutes, right? And I have to spend some time today. I want, for the people who missed last week and whatnot, right? I want, to have a little chat with them to show them where to get all the work they missed and whatnot to come fully prepared for tomorrow, for next week. How much of, but just a small thing here, how much of you all did the quotient rule already in school? The quotient rule is used when you have 2 groups of X not being multiplied, but being divided by each other. So the product rule is for multiplication, and the quotient rule is for division. How much of you all saw this in school already? The quotient rule. This is what we'll be starting from next week. This will be our starting point next week. Let me know on the chat. All right. Even if it did it, it doesn't matter. I mean, no harm in doing it a second time, right? I'm sure you'll pick up on something, right? Right. All right, guys. So for those who don't know how to access the recordings and homework and things, and you really want to try to get back on track, stay back now. I'll gladly explain how to do that, because one of the worst things to do is to get lost in ad maths class. It's not like maths, where if you miss a couple of classes, you can still rebound. In ad maths, you miss too much classes, like 2-3 classes, and that is it. You're gone. All right. So those who want to stay back, stay back. But those who need to leave, have a very good Tuesday. Enjoy your Tuesday. And some of you all have Spanish tomorrow, I believe. All right. Take care, guys. All right. No problem, guys. You're welcome. All right. So for those who staying back, I just want to, I'm going to send you a direct link. For those on YouTube who require the links, right? Like if you don't know how to access the homework, you can always just WhatsApp me on, well, WhatsApp. I don't know why I said it like that. But if you need to access the homework, right, just WhatsApp me and say, hey, you're a student on YouTube. Make sure you say you're a student on YouTube, and you just need the link to access the homework and recordings and things. And I'll gladly send it to you once you mention that you are a YouTube student at the moment. Okay. All right. So that's my number there. For those who want the link to the classes are on Zoom right now, I'm sending you the link. Check the chat. I'm sending it 3 times. You just need to click it once. Just click it once. When you click on that link, you will go directly to this page that you are seeing in front of you, right? It's every single subject that has been done for the summer, right? So if you need to, the first one is the subject and dates, the middle column is the class recordings, and the third one is the homework. It's real easy to use. If it's AdMats you're looking for, just scroll down until you see Thursday, because we have AdMats on a Thursday. You will see the 2 recordings that you missed and the entire summer homework. All you need to do is just click on it and you will access it. It's literally that simple. Okay? Do you all understand? For those who stayed back, you think you know how to access, make sure it works first. You can double check it now, make sure it works on everything before you leave, and confirm with me now, because I really want you all to get back on track for next week, right? Let me know in the chat before you leave, so I can feel confident that you understand.